Hello everyone, welcome to Unravel Logic channel. Today I'll be covering arithmetic mean. Let's start with the formal definition first. So the definition of arithmetic mean goes like this. So it's one of the fundamental measures of central tendency. So let's write one of the fundamental measures of central tendency. In simple terms, it represents the typical value of a set of numbers. So, typical value of a set of numbers. As if you were to look at a set of numbers all at once and derive a number that can represent all the numbers in that set. Example, we have data on the consumption of slices of bread by a person during breakfast over the course of 5 days. Okay, so consumption of slices of bread by a person during breakfast over the course of 5 days. So data is like this. D1, they consume 4 slices of bread. D2, 3 slices. D3, 4 slices. D4, 6 slices. D5, 3 slices. If you were to get a general idea as to how many slices of bread that person typically consumes in a day, then you would intuitively do something like this. So you would add everything, 3 plus 4 plus 6 plus 3, come to 20 slices for 5 days. Now since you want to find out how many slices of bread that person would typically consume in a day, in one day, so what you would do is 20 over 5, 1 day, right? So this is a simple calculation that you would do. But why will you even want to find this number, right? So why? Let us add some context. So let's add some context to this. Let's say you are responsible for bringing groceries like bread, for example. In our case, you would like to calculate the amount of bread you would need for a week per person, right? In our case, assuming only one person, you will have to get a minimum of 4 slices of bread so that the person is satisfied and they are not left hungry, right? So in our case, you would have to buy a minimum of 4 slices of bread to satisfy that person. You can obviously buy more than 4, right? You can have some margin, right, in case the person gets hungry, more hungry than usual, right? So you should have a backup of 2 breads, right, more, so you can buy 6. But at minimum, this calculation, the calculation that we did, gave you an idea that at a minimum you will have to buy 4 slices of bread to satisfy that person. So let's talk about the mathematical formula. So this is x bar equals to x1 plus x2 plus x3 plus xn n. So what does each term means, right? So this is read as x bar, this is bar, value 1, value 2, value 3, value n, and this is like total number of values. Yeah, in formal notation this is also written something like this, right? So this is xi over n, where I equals to, I ranges from 1 to n. So this is another way of writing this formally. Now let's understand what is this formula actually doing. What is the formula actually doing, right? Let's understand. We sum the numbers in the set for which we are trying to find a fair representative, right? Notice the word fair representative, right? So let me repeat. We sum the numbers in the set for which we are trying to find a fair representative. Then we divide by the total numbers in the set. This is as if we were to divide something equally, right? As if we were to divide something equally. Now if we divide some quantity equally, we are striving for some kind of fairness, right? And this is where this word or this term fair representative comes into picture, right? Fair representative. We have a set of numbers, we are trying to find a number which can represent all the numbers in a fair manner, right? Now read this line again, as if we were trying to divide something equally, right? So that we are fair in terms of distributing things. And this is what the formula is actually doing. So let's understand using another example. Yeah. Let's say we have 2 orchards of oranges. We have harvested thousands of oranges from each orchard. We would like to know how much an orange from each orchard will typically weigh. So we have 2 orchids. Orchid 1, orchid 2, and we have harvested thousands of oranges from each orchid. But since we cannot count exactly how many oranges we harvested and how much each orange weighs, so what we do is we pick 10 oranges randomly from each orchid, orchid 1, orchid 2, correct? And then try to apply the formula for arithmetic mean, right? Because what we want to do is we want to find how much an orange typically weighs from each orchid, right? So for orchid 1 we have 25, 27, 30, 29, 27, 25, 23, 30, 25, 26. For occurred 2 we have 30, 32, 37, 32, 28, 27, 35, 35, 36, 37. Now we apply the formula on ORCID 1. So for ORCID 1, (25 plus 27 plus 30 plus) we add everything till 26, divide by 10, we get something like 26.7, right? And you can verify this. I have already given the numbers. In the interest of time, I pre-calculated this. Then 30 plus 32 plus 37 plus till 37, yeah. Then we divide by 10, we get something like 32.9, right? So we can clearly see that oranges from ORCID 2 tend to be heavier as compared to oranges from ORCID 1, right? So we can simply say ORCID 2 greater than ORCID 1 in terms of how much a typical orange weighs from that particular orchid, yeah? So ORCID 2 greater than ORCID 1. We can also say something like this. Let's make a statement now that on an average, oranges from ORCID 2 tend to be heavier than oranges from ORCID 1. So let's notice two words here. One is average, another one is tend. Right? So average is another word for arithmetic mean, and tend here means tendency, right? So oranges from ORCID 2 have tendency to be heavier than oranges from ORCID 1, right? Why the word tendency? Right? Because we are not sure, that we cannot say that all the oranges from ORCID 2 will be heavier than oranges from ORCID 1. Based on some sample oranges that we picked, which had different weights, right? We can say, or we observed, right, that oranges from ORCID 2 have a tendency to be heavier than oranges from ORCID 1. Correct? That is the word tendency. That is the reason we are using the word tend. Okay? And that is the reason the definition says that arithmetic mean is one of the fundamental measures of central tendency. Okay? Tendency. That is the most important word here. Okay? Now, let's ask another question. Is average or arithmetic mean always a fair representative of the set of numbers? So, is average or arithmetic mean always a fair representative? What I mean to ask here is, or what we mean to ask here is, can we always trust arithmetic mean? Okay. So the answer is, let's try to find out by using some examples, right? Let's see ourselves, right? Instead of relying on some definitions or some stated facts in some book or somewhere, let's try and understand it ourselves. Okay. So let's say we have a set of numbers 10 plus 9 plus 11 plus 8 plus 10. Okay, and these are 5 numbers. Total is 48. Divided by 5, we get 9.6, right? So 9.6 is the average of these numbers. Let's take another set, but this time we keep 3 numbers same and we change the last 2 numbers. Okay, last 2 numbers are 17 and 13. Okay, 5 again, so this would give us 60 by 5, so it's like 12. Okay, another set 10 plus 9 11 plus 6 plus 4. This is 5. This is like 40 by 5. We get 8. Okay. Now, if you notice, we are only changing 2 numbers. Okay. But let's see how our averages or arithmetic mean is varying by changing last 2 numbers. Right. So, if you see 17 and 13, right, these numbers tend to be larger than the other 3 numbers. So this resulted in increase in the arithmetic mean. Okay, so these 2 numbers 17 and 13, so we can call them as outliers. I will explain what outliers mean, but similar thing is happening here, right? So these 2 numbers, by changing these 2 numbers, we are seeing that our arithmetic mean is also changing. So what we mean to say that there can be some numbers in your data set that do not follow the general or central tendency of the numbers of the other numbers in that set and might affect your average or arithmetic mean. In such cases, the average won't be the correct representative of the set and we might have to remove the outliers. Okay. Let me repeat. There can be some numbers in your data set that do not follow the central tendency or general tendency which the other numbers are following and might affect your average or arithmetic mean. In such cases, the average won't be the correct representative of the set and we might have to remove the outliers. Okay. Now, what is an outlier? Right. So outlier is something a number that does not follow the trend or the tendency that all other numbers are following. Now, let's understand some properties of arithmetic mean. What happens if we multiply or divide every number by a constant? Each number by a constant. So let's take this example where our average is 8, right? So let's multiply all the numbers by 5. So 5 times 10 plus 5 times 9 plus 5 times 11, 5 times 6 plus 5 times 4 over 5. This should give us something like 5 times 40 by 5, which would give us 5 times 8, right? So as you can see, 8 was the original average. After we multiplied every number by 5, what we are getting is 5 times 8. So what we can say is that if we multiply each number, multiply or divide each number by a constant, the average would also get multiplied or divided by that number. Okay. So you can try for division because essentially multiplication and division are the same things, right? Division is like multiplication by a factor or fraction, not factor. Okay. What if we add or subtract a constant to each number? Okay, so let's say 2 plus 10 plus 5 plus 2 plus 9 plus 2 plus 11 plus 2 plus 6 plus 2 plus 4 over 5. What you would get here is 10, right? You can try and calculate this, but the original average was 8, right? So, and 10 is 8 plus 2. So what we can deduce or what we can see is that if we add or subtract a constant to each number, the average would also get incremented or decremented by that amount or by that constant number. Let us see some plots now. First plot demonstrates the weights of oranges from two orchids, the orchid example that we saw. So the left plot demonstrates the weights of oranges from orchid 1. The right plot demonstrates the weights of oranges from orchid 2. Now if you remember the result, we concluded that orchids or oranges from orchid 2 tend to be heavier than oranges from orchid 1, and this is what we see in these plots. So if you see, all the green dots in the right plot are a bit higher than all the orange dots on the left side. Yeah, and even if you see the mean line, which is the red dotted line, that is higher for orchid 2, and our result was the same, right? That oranges from orchid 2 tend to be heavier than oranges from orchid 1. So this demonstrates the weights and the data is same as we saw in our example. And if we see the last plot, right, which is the second plot in this page, it has three subplots. The first plot is where there is no outlier in the data, right? So you can see that the red dotted line is very close to all the data points, which means that the red dotted line or the mean or the average is a fair representative of the numbers in the set. In the second subplot, which is the high outlier scenario, right, wherein you can see that there is one point which is way higher than all the other points, which is this point, right? And because of this, the mean line or the red dotted line is pulled up as compared to the no outlier scenario. So you can see that if we have an outlier on the higher side, then it will be responsible for pulling up the average towards itself. Now, if you see the third plot, which is the low outlier scenario, you can see that this plot has two outliers which are on the lower side as compared to the other numbers, and these two outliers are responsible for pulling down the mean dotted line, which is the arithmetic mean line or the average line, right? So we can conclude that if the outliers are on the lower side, they will be responsible for pulling down the average towards themselves. Yeah. So this covers our video on arithmetic mean. If you liked my video, please like, share, and subscribe. And stay tuned for more videos coming up. I will be creating next videos on median and mode, which are also fundamental measures of central tendency along with arithmetic mean, and we'll also see how do they compare with each other and when to use which. Thank you for watching.